Alright, we're going to look at how to check inequalities. And generally you do not find information on this in a textbook. The first inequality is was a two-sided inequality with a less than or equal in between. And I calculated it, and the answer that I got was x is greater than or equal to 1. In order to understand how to check an inequality, you really need to understand the graph of the inequality. And this inequality has a solid circle at 1. See if I can get this going. And then the points in the solution are to the right of it. So really there are two things you need to check about it. You have to check that the 1 is in the right place, or the circle, the boundary point, and that you've shaded the points to the side where the solutions really are located. So the first thing we do is check the number 1. And if that is really a boundary point for a two-part inequality like this, it is going to make the left side equal to the right side. So they should be equal there. And so we'll check that by using the calculator, and it's fairly easy to do. And the buttons we use, again, are written on the bottom here. We're going to start by turning it on, and we start with the y equal key, and let's clear out what's in there. And then for y1 we'll put the left side, which is 3/5 x plus 1, identically as it is there, minus 2x. And for y2 we'll put the right side, which is x over 2, x divided by 2, minus 9 divided by 10. And we'll go to check table set, and it does have independent on ask, so now we can go directly to table, and we'll use the table for checking. And we're going to delete what's in there by hitting delete. Now the first thing we're going to check is 1, and it should give us a value on the left and right that are equal, and if that happens, we're happy. Okay? And it does. It gives us a negative 0.4 equals a negative 0.4. And I advise you to keep a little table like this because it enables you to see that you've checked everything. Alright, and the next thing we have to do is check some point that's over here on this side of 1 to make sure that it makes the left side less than the right side. So the point that makes it equal is the 1 itself. Everything to the right of it, one side will make it less than, and the other side will make it greater than. And we want the solution to make the left less than the right. So let's pick a number like 5. Anything works. And so we'll put 5 in. Up, 5. Up, I did 55, didn't mean that. Alright, let me try that again. 5, and hit enter. And we get negative 6 on the left side and 1.6 on the right, and that is a true statement. And so both check, and so we know that we do have the solution correctly. Alright, next we're looking at a three-part inequality, and the part with x in it is in the middle. Again, it's useful to think of the graph here. I've written the solution here that I came up with, that x is between 2/3 and 5/3. And if we indicate 2/3 on the number line, we'll have a open circle there, and 5/3 will also have an open circle. And we're talking about all the points between. Generally, it's sufficient to just check those endpoints, 2/3 and 5/3, because you're going to be getting the points in between them, because this was a between inequality to start with. When you get them, one of them should be equal to -1, and the other should be equal to the other boundary, -4. And this is not a very difficult problem to check. Let's go ahead and look at it with the calculator here. Alright, so what we'll do is go to y equals again, turn it on, and we really only have to put in y1 because there's only one expression with x, and it's the one in the middle, and we're just checking the two boundary points. Alright, and so let's clear what's in there and go up to y1, and then put in put in the expression 1 minus 3x, and then go to the table feature, delete what's in there, and then put in 2/3, 2 divided by 3, enter. It'll enter it as a decimal, and we see that when we have 2/3, we get the value -1, and that's okay. And then hopefully we'll get -4 for 5/3. Let's enter 5/3 next. 5/3 is 5, divided by 3, and hit enter, and we get -4. So if entering one endpoint of the solution gives us one of the endpoints of the original statement, or boundary points, and if entering the other boundary point of the solution gives us the other endpoint, we can be confident that our endpoints are correct. We still have to make sure that we used the right type of boundary, like if it's an open or closed one, and otherwise we can be pretty sure that it's what's in between the two boundaries too. Alright, well, this is actually an absolute value equation, not an inequality. And to check it requires checking as all equations do. So let's go to y equals, put the left side as y1 and the right side as y2, clear out what's in there, and we actually can put absolute values in. So let's watch how that's done. We start with 3, and we want the absolute value of 4x minus 3, and this is where it's found. It's found under the math key. You have to move to the right to num, and the very first thing is absolute value. And so hit enter, and you want to have the absolute value of 4x minus 3, and then we'll close the parentheses there, plus 1. So that's 3 times the absolute value of 4x minus 3 plus 1. And then the y2, we'll move down, is equal to 10. The second thing we'll do is check table set to make sure that independent is set to ask. And then the third thing is to go to table, delete anything that's in there, and enter your first answer, which is 0, and it should make both sides equal. It does. Makes the left side equal to 10 as well as the right, which was 10. And then your next answer is a negative 1.5. Hit enter, and that doesn't work. And basically that tells you that you need to go back and see why it doesn't work and find out what error you may have made. And so I'll pause and do that. And I checked my work and found that it was a simple mistake, and I will correct it by erasing the negative sign. My error was that it should have been, or it appears to have been, a positive 1.5. And then I will go ahead and try that. And it appears that 1.5 might be the answer. Hit enter, and sure enough, 1.5, the positive 1.5, gave both sides equal. So if you find that you have an error, then it's up to you to go back and figure out what the error was. Mine was just a copying error. Alright, our final problem is going to be checking the inequality absolute value of 5x plus 1 is greater than 3. And we have two parts to this solution. We've got x less than negative 4/5 union x greater than 2/5. And to check it, you really need to understand the graph first. I'm going to go ahead and graph that. If we graph negative 4/5, we would want to have a open circle there, and the points that are less than that are to the left of it, so we have those points over there. And then 2/5 is to the right of negative 4/5 somewhat, on the other side of 0. And the points that are solutions there would be points, well, first of all, it's an open circle there at 2/5 and be points to the right of it. Now with the check, we're just able to find out that our boundary points are correct and that the shading is in the right direction. So first we would check negative 4/5. And we would want to see that it makes it equal to 3. And we would then check negative 2, well, we would check a point to the left of negative 4/5, and we would want the absolute value of that to be greater than 3. Okay, I got interrupted, so let's continue where we left off. Let's just check that one side. Check the boundary point, and then we'll do this other side when we get that one done. Alright, so let's go to y equals, turn the calculator on, y equals, and let's put in the absolute value. Well, let's clear out what's in there first. And let's go up to absolute value, which is on the math, and go over to num, and absolute value is the first thing again, of 5x plus 1, close parentheses. And on the, let's just go ahead and put in 3 there. And remember, the boundary points are supposed to make it equal to 3, and the other points are supposed to make it greater than 3. So I'm going to put in enter, and well, let's go to second window, table set, make sure it's set on ask, and then go to second table and delete everything that's in there, and put our first boundary point, which is negative 4/5, and it should make the left side equal to 3, and it does. Okay, and then let's pick a point to the left of negative 4/5 in the solution part, And one point might be -2. So let's just use -2. And it should make the number on the left bigger than 3. And so let's pick -2. And it makes it 9. And 9 is bigger than 3. And that's just fine. Now, so this part checks. And let's go to the right where 2/5 is the boundary. And we'll enter that, and that should make it equal to 3 because it's a boundary point of the solution. And so let's put 2/5, 2 divided by 5 for the x value, and that makes the left side equal to 3. We get 3 equals 3. And then pick a number bigger than 2/5, like 5 or something. It doesn't really matter what. And it should make the absolute value of that, the left side should be bigger than 3. And so we'll put in 5. We could pick any number would be fine, and hit enter, and we get 26 is the absolute value. When you put 5 in there, you get the absolute value of the number is 26, and 26 is greater than 3. So everything checks. In particular, we have the right boundary points, and we have the right parts of the number line shaded. And so that is the way you do a check for an absolute value inequality.